What's up guys, it's Avery here, and today we're going to be talking about all of our units in Science 10, summarizing them, and then tying them into the class storyline. You already know it, call it the stewardship. So let's talk about Unit 1, Space. Space is fantastically enormous. It's impossible to even imagine. It's thought to be 93 billion light years in diameter. That's astronomically big. It's so big that if we were to compare Earth to the universe, it would be equivalent to a quarter to North America. So how did something this big even come into existence? Well, that answer lies 13.8 billion years ago. What happened 13.8 billion years ago, you might ask? The Big Bang. The Big Bang was a massive explosion, and that formed our universe. Don't believe me? Look at the evidence. There's still cosmic microwave background remaining in the universe, and that's microradiation. Also, the galaxies are still moving away from one point in the galaxy due to the strength of the Big Bang. And obviously that one point in the galaxy is where the assumed location is of the Big Bang. The universe is just so big. There are about 300 billion planets, and there have been 500 solar systems located up to this date, and that number is still increasing every year. Billions of stars are in our universe, and maybe even trillions of galaxies. Space is amazing. So we've been talking about some pretty big things, actually astronomically huge. Let's shrink things down a little, actually a whole lot. We're going to talk about things so small you need a microscope to see it. That's right, we're going to talk about DNA and genetics. First, let's talk about DNA. DNA is in all living things. It controls everything in our body, from what we look like to our personality. All of that is to the most microscopic detail. There are three types of genes: homozygous dominant, homozygous recessive, and heterozygous. Every person has one of these for every trait in their body. To find out the odds of what their child will be, each parent finds the genotype of the trait in question of themselves. And then you get a Punnett square and add one parent's genotype to the top and one to the left side. You run the Punnett square, and then you will find out the odds of your child's trait. Unfortunately, sometimes people's genes go wrong. Children can get genetic disorders and most likely live with them for the rest of their lives. Some of those include Down syndrome, Angelman syndrome, and hemophilia. Some of these diseases are linked to gender as well, as the gender can alter if you have the disorder or not. You can also often identify a genetic disorder before birth, but there's not much that you can do about it. Not all traits have to be one or the other. For example, if a red flower and a white flower reproduce, their offspring could be pink. That's called incomplete dominance. The offspring could also be red and white at the same time, and that's called codominance. So let's talk about selection, natural and artificial. What's the difference? I'll tell you. Natural selection is when nature affects a species. So for example, a river comes and forms and splits up an insect colony. Artificial selection is when humans interfere. So, for example, a company comes and builds a wall and splits up an insect colony unintentionally. So that's the difference. And also when humans come and interfere intentionally, that is selective pressures. Genetics can be applied for great reasons in real life. You can edit genes so that genetic disorders can be stopped or made much better. If someone wants, they can even change what they look like. Genetics is an amazing thing, and DNA is what gives diversity to all living things. Now let's talk about something else. Let's go even smaller, much smaller than DNA. It's time to talk about atoms and chemistry. Almost all of chemistry has to do with reactions, and those reactions are the physical form of an equation balancing. All reactions have an equation, and that equation is the numerical version of a reaction. On one side, there's a number of elements and atoms before the reaction, and on the other side, it's the same elements and atoms, but rearranged into a different order with different amounts. It was changed in balance because of that reaction. Reactions can come in many different forms. They can come in the form of fire or explosions, bubbling or frothing water, or changing colors. There are 6 types of reactions: synthesis, decomposition, single replacement, double replacement, combustion, and neutralization. combustion often appears in the form of fire or explosions. Our class learned how to name formulas and make formulas out of a name. We also learned the difference between covalent and ionic compounds. The difference is that covalent is a compound of two nonmetals, and ionic is a compound of opposite ions. Energy is always around us, working with chemical and physical changes. All the chemical reactions we have talked about go along with the changes in energy. For example, energy from the sun converts water and carbon dioxide into chemical energy. Energy cannot be created nor destroyed. There's the same amount of energy in the world as there was a million years ago. When bonds break during a chemical reaction, it requires energy, whereas reforming bonds releases energy. Let's move on to our final unit. All this talking's got me tired. I guess I've run out of energy. Energy is all around us. It's what causes all movement in the world. Energy can come in many different forms. It can be potential, like when a ball before it rolls down a hill. Kinetic, energy while in motion. Thermal, internal energy according to temperature. Electrical, like power from an outlet. Chemical, like when during a chemical reaction, the energy released. And nuclear, the energy that is released during nuclear fission. We did an energy home audit this unit. We learned about our home's energy usage and ways that we can improve. So basically, I had to evaluate every single energy-related aspect of my house. Seriously though, it was an educational experience and I learned a lot. I discovered vampire appliances and energy-saving appliances. I also found out what the average temperature is in my house. By the way, it's 24. There's always energy moving in and out from the atmosphere. There's solar and infrared energy coming into Earth's atmosphere, although a lot of it is being reflected back up to space by clouds, aerosols, and Earth's surface. Although about 50% of solar energy is absorbed by Earth's surface. In time though, energy balances out, and because it's always going in and out, 100% of what comes in always goes out. So at some point, all of it will go back up to space. So, as you've heard, energy is all around us. It plays a huge part in our everyday lives, from turning on a light to turning on our car. People are trying to conserve energy, and that's why we did the audit, so that we can turn down our energy usage and help our environment. So, energy is conserved, and its transformation affects all living things and its environment. So, we've covered everything now. Space, genetics, chemistry, and energy. But how does all this tie into the class storyline, called the stewardship? Well, I think I have your answer. And spoiler alert, it all ties in perfectly. So, the universe. What about that one? Well, God has created such a beautiful creation. When we're learning about it and seeing it, it is worshiping God. So, we are being stewards over creation when we take care of it. But we need to learn about the universe first before we can be stewards. We are called to stewardship not only over Earth, but over all of God's creation. So now that we've learned about His creation, we can be stewards over it. Genetics. When we learn about all these minuscule details that perfect us, we are honoring God. When we learn about that, we can help people with genetic disorders, and therefore we are caring for God's creation. If we know how to help these people and do, we are being stewards over God's creation as well. So, learning about genetics does help us appreciate God's creation and how we can care for it. Chemistry fits as well. People can use chemistry to learn about the world and help serious problems in it. It helps scientists keep tabs on climate change, and it also helps people's health. Environmental chemistry helps the environment as well. When we learn about chemistry, we are getting closer to helping the world with environmental issues. When new types of technology come out, it helps the world environmentally, like saving energy or using less resources. So when we learn about this, we are getting closer to helping the world with chemistry, so that makes us stewards. Energy also ties in. When learning about energy, we did a lot about saving energy and conserving it. In fact, we did an entire project just on conserving energy in our homes. The audit helped us become better stewards and cut down on energy use. The environment was helped and our knowledge on energy grew. We also went to the State Falls Powerhouse, where they have energy-saving equipment there as well, so that they could use less energy. So learning about all that was great for our knowledge, and it most certainly helped us learn more about energy saving. All that made us better stewards, and now we are called to be stewards over our creation. So, to conclude, this was a great year. We learned all about space, genetics, chemistry, and energy. We learned how all our learning tied into the big ideas, and how the units tied into the class storyline called the stewardship. I learned a lot, I had a good time, but most of all, I learned how to be a good steward over the creation. Thank you guys for listening, and I hope you're still awake. See you guys next year. This is Avery Cruz, signing off for now.